KDB and how to do is KDB is a kernel debugger. Okay, so when you do launch anything via KDB, what happens is that the application starts not remotely, but it will start on the same system basically. Okay, so we will and it will enter the KDB kernel debugger console, and you can do whatever you want inside the kernel debugger. Okay, so I will show you how to do that. Okay, so on the same kernel, we will do the KDB actions. Okay, so I will just show that now. Okay, so if you check out here, only thing is parameter what I have changed is I'm not using KGDB, I'm using KGDB doc. That is fine. I want it to come on the serial console, that is okay. But I have not used KGDB wait because this is not running via KGDB. Okay, so once we run it, basically, so now your system runs. Okay, but kernel debugger is not triggered. I want to trigger the kernel debugger. Okay, so what I will do is echo G. Okay, so I will use the same proc interface to trigger the. Okay, so immediately after this, it enters the KDB console. If you check out from the current shell, now it is in the KDB console. Okay, so using this, if you want to know what all things this supports, so you can check out. I can see the using this, I can get the backtrace. What is the current function that is running? Okay, so then after that, if you want, you can just press help also here. Okay, so if you check out here, there is you can put a breakpoint also here. Okay, so you can display the stack trace. Basically, this is the using this you can put a breakpoint. It's like a normal debugger which is available inside this only. Okay, so then after that you can put a breakpoint wherever you want inside the function. Assume I want to put a breakpoint at a breakpoint. Okay, so schedule. Okay, now the breakpoint is there at schedule. Okay, now if you want, we can run also. Actually, if I want to clear the breakpoint, I can clear the breakpoint. I can single step and I can see what is happening. Okay, so I can dump all the information. I can dump all the debugging information. Okay, so then after that, if I want to pass, I can pass a kill signal to something. If I want to see the D message buffer, I can see all the LS mod information. Okay, so from KDB, if you want, I can run to KGDB directly. Okay, so assume running on this current system is becoming complicated. So if I run KGDB, immediately it will enter into KGDB mode. So then the remote application can take the control and it can run. Okay, so that is also possible. Okay, so I can print the environmental variable. Okay, so I can print the backtrace. Okay, so I can print the content of the register. So what is the content of the register? By telling RD, I can print what is the content of the register at any point. Okay, so then after that, I can do a raw dump of the memory. Okay, so all those things are possible using this particular mechanism basically. Okay, so all these things are possible. So then after that, I can do single step and I can debug. Okay, so it is single stepping and it is running. Okay, so now all these things are possible. Okay, if I once I have done with KGDB and if I want to exit, I can tell exit, quit. Okay, so I think we can quit the KDB also. Give me a second. Actually, yeah, we can kill and you can get the summary of the system what it is. Okay, so all those things basically you can set breakpoint and you can put you can enable the breakpoint wherever you want. Basically, as I showed now. Okay, so you can do all those things basically. Okay, and if you want, you can raise the things. Basically, you can see the process, all the process which is active at that point. Okay, so all those things can be done and it can be viewed in the current thing only. Okay, so and if you want basically anything you can do from this and you can do at any point of time and you can debug. So now it has entered the KDB console. Okay, so we can do whatever we want. We can do single stepping. Okay, so we can do single stepping and it's doing instruction single stepping. Okay, so all those things we can set and we can see the backtrace what is happening. Okay, so all these things we can see and we'll get the all the functions what is happening. Okay, so all these things is happening and so basically we set we can set breakpoint wherever we want, but only thing is this happens on the local system only. Okay, but this feature what is supported in this is very minimal. So what you can do is you can view what is going on. Okay, then you can check out what is, if you want at any point of time, if you want to get more information, you can give help. Okay, so you'll get to know what all things are available as a part of this basically. Okay, so if you want, you can print summary information of the system, basically what is the current system all about, and you can get the PS information, what process was running at that particular point. Okay, so you can check out, we'll get to know that this is the process that was running. Okay, so basically then after that I can also do all the things basically. So basically in this I can debug in the command line and understand and see what is going wrong at any point of time, and we can debug. Okay, so that is the reason this KGDB is useful in this particular angle basically. Okay, so using this we can do, and we can analyze and we can work with it basically. Okay, this way, but as I told you, this is available on the same system. So assume if my system I've enabled KDB. Okay, and if I pass this sys request, immediately it will enter into the KDB mode. Okay, and once it enters the KDB mode, so what will happen is I can do whatever I want and I can execute. Okay, for example, if I want to continue execution, I can tell go. So it is always since there's a breakpoint here, it is always hitting this particular breakpoint. Okay, but I can execute. I can just execute and I can continue running the program. Okay, so if you want, you can see the breakpoint what is available. For example, if you want to clear the breakpoint, you can clear the breakpoint via BC. Okay, or else using BL, you can set. You can see what is the breakpoint. Okay, so let us assume that I'll see the breakpoint what is set. Okay, so there is one breakpoint set currently which is enabled at some particular address. Assume that I want to which is that scheduled at address something, so I will disable that breakpoint. So for deleting a breakpoint, we have to pass this option basically. If you see this help, BL is BC is for clearing the breakpoint. Okay, so I will clear the breakpoint. Okay, so breakpoint is cleared. If I see BL list, there is no breakpoint. Now, if I tell go, it will be running. It will continue to run and it will exit basically. Okay, so it has run and it is exited that particular point. So what I can do is, the moment I enable, if I want, a moment I press G again, basically to that particular thing, proxies. Okay, so it will enter. Okay, so the thing is that currently what I'm doing is I'm using echo G to enter to this mode. Okay, so I can use the keyboard also to enter to this mode without anything, without any problem. Okay, so assume this is the case, and if you use alt, print screen and G, currently this is not supporting alt function print screen, and I press G. Okay, so if you press it, basically it should immediately go into the GDB mode. Okay, so you need to check out, if you remember, if you know which is the sys request key on your keyboard, what you can do is you can push your kernel to the debug mode wherever it is by pressing this sys request key plus G key. Moment you press that, immediately it will enter the debugging mode. Then once it enters, it will go to KDB mode. Then after that, you can do all the analysis and find out what is going on. Okay, so in this case, if I enter now, it will go to KDB mode now. So what I can do is I can check out what process was running. Okay, so then after that I can look at, for example, if it is hung, I can look at even the D message also and find out what was happening in the D message, why did it hang. Okay, so that also I can figure out, or else I can do a memory display also. For example, assume that I want to display some memory content. I can display that memory content also. What is the content of that address? If I know the correct address, okay. So assume I will take PS. The PS is available at so and so. Assume it's available at so and so address. So I can display that particular address and figure out what is happening. Okay. So like this, there are a lot of options that is available in KDB. So you can moment it sunk by using the shortcut key and pressing G. So immediately it will enter the KDB mode and you can start debugging and figure out what is happening in your subsystem. So basically same like your KDB, you get all the information, like you get all the process information. Okay, you can peek into the memory. Okay, you can modify the memory. Okay, so then you can do whatever you want basically. Okay, so if you want, you can see the content of the register. You can see the call stack, what really was the call stack when it is hung or it is crashed. Okay, so all those particular information can be fetched. Okay, so then once it is fetched, what you can do is you can debug and figure out what is going on. Okay, so all those things are possible via this particular KDB. Okay, so you can also configure such that in case of crash, it might enter KDB. So basically at that point, what you can do is you can debug and you can understand what is going on, and you can work with that particular thing. Okay, so now assume if I press KGDB. Okay, okay, now it has entered the GDB mode. Okay, so now only way I can connect to the GDB mode is via connecting via serial console. So what I will do is I will just kill it. Okay, so since we were debugging, I will just connect target remote 1 2 3 4. Somehow it didn't get connect, but 1 2 3 4 was the address what I gave, right, to that particular guy. I didn't pass that serial equal to option. The serial equal to option is not passed. So because of this, it is not routed to the TCP IP. Okay, wait a second. What we will do is serial equal to TCP. No, wait, we can do that basically. Okay, so basically if we set all this option, and so currently at this point what is happening is, so basically from KDB we can move to KGDB and you can do a remote debugging if you feel this is not giving much information. Or else what you can do is via KDB you can see all this information what is available at this point, and debug and find out what is going on in the system at that particular point and debug. Okay, so it's same like your KDUM, you can analyze, and but this is much more than KDUM. Here you can, this is your running system, you can put a breakpoint. Okay, so and you can see all the things. For example, you can see the stack of your process, what is happening. Okay, so you can stop at a particular process, you can see what is a particular process. Okay, so you can switch to particular PID. All those things are possible using this basically. Okay, so let us give me a second. What we will do is PSAX, let me kill that, kill -9 66661. So it is stopped. Let me run this now. So echo G. Okay, so proc k sys IQ trigger. So it has entered KDB. So yelp. Okay, so this guy tells that according to this manual. Okay, so what you can do is you can get, you can if you see, if you look at this basically, you can give the PID and you can shift to the another task. Okay, so let me see which process is there. Okay, so this process is there. So what I will give is I'll give PID of this particular task. Let me assume that I want to debug this other SH 837, or else let us see that I want to debug this particular program 814. Okay, so I will type PID 814. Okay, so this is my current process. Okay, so I can do a back trace of that particular process, what was happening when that particular process is running. Okay, so then I can do if there is a code available, we can list also. Okay, so now what I can do is once I do I can check out this and I can put a breakpoint also. Basically what I want, I can put a breakpoint and we can continue, and I can tell go also basically. Okay, so that is also possible. Okay, so else if I give that, enter that command again, then if I see this PS, so again it's at the same thing. Let us assume that I want to check out what this write back is doing. Okay, so I will tell PID 343. Okay, so then I will look at the back trace. So there basically what has happened is it has come till here. Okay, it has come till schedule and it has put a breakpoint and it has scheduled this particular program. So at this point, I see there are all the programs which are daemons, and there is one program which is sleeping, and there is only one active process which is running. Okay. So now if I come to this program 843, okay. So PID 843. Okay. So if I do backtrace, so I get to know that in this backtrace, since I used the Control G command to enter this, okay. So this is what is happening in this particular case. Okay. So this is happening, and this is what this is the call stack what we are seeing basically. So basically, I wrote some data. From that data, it triggered a KGDB breakpoint, and that KGDB breakpoint internally called this console, KDB console. Okay. So all these things are happening with respect to this particular thing. So basically, we can get all this information. So from this, all this information, what we can do is we can debug our kernel and we can find out what exactly is going wrong. Okay, so this is how we can get that KDB console. Why you can see normally since this is a simulated version, I am doing all those things via echo G command. Okay, so on your keyboard, you need to find out where this Control Alt. For example, this is the command what we are running. Magic Q. Okay, so what you have to do is you need to go to this and press. For example, ours is a x86 system, so we need to press Alt. This sys request key, we need to find out what it is. Okay, so normally it will be mapped to the print screen key. Okay, and then you need to press the command what you want. So the moment you press, immediately it will go to the KDB console and you can start debugging. Okay, so this is one thing. This way you can enter the KDB. So currently I'm using this proc. If on your system, if on some keyboard a sys request key also, you can use the sys request key and pass push a command to your thing, and you can start working. So then you will be able to see this KDB console, and you can work with respect to that particular part. Okay, so did you get till this point? Hello?
Yeah.
Yeah. So this way you can do it. So basically what we got to know is we got to know how to debug via KGDB. Okay. Then we also got to know how to debug via KDB. Okay. So that is two ways of doing it. Okay. Now we will look at, I think yesterday you asked about Pstore also, right?
Yeah.
So we will see key store. Pstore is something like it will store all your oops messages. See, normally the oops messages, right? You can store via the Pstore is nothing but your persistent store. Okay, so I will show you how to configure it. Let me execute this. Come out of this. Okay, and
So
exit
that
won't work.
reserving the memory, right, to store the this oops
Yeah,
messages.
yeah.
So basically, it's in the swap memory, or actually how, or
You need to reserve the physical memory for it in the DTB basically.
okay. So
I will
suppose
just start. I will just show you. Give me a second. So yeah, I will now. I think yeah, I have it. Okay. Yeah. So I will just share it with you now. Yeah, we're at the right place. Okay. So here normally what we need to do is right in this DTB, right? We have to reserve we need to reserve a memory. In that reserve memory, what we need to do is we need to allocate a memory for oops basically. So that will be used for Pstore basically. Hello.
okay. Yeah, yeah.
So so that way we need to do it. I will just show because we need to put it in the GDB. Without that, if you don't reserve the memory in the DTB, right, it will not work actually. Okay. So just give me a second. Yeah. So please store. Give me a second. Yeah. Okay. I think now it is. Now we have the information. Yeah. So basically, you need to have some reserved location. Otherwise, it won't work. Okay. So I will just show it to you. This is the one. Okay. So basically, normally what will happen is you need to reserve a space called ROM oops. Okay, so all the messages that comes in ROM ops will end up in Pstore basically. Okay, so basically Pstore is nothing but your persistent memory. Okay, this is like a persistent storage. Even though it is in RAM, why it is called persistent is that this particular region of memory, right? Whenever you do soft reboot, right, it will not go. It will be always persistent. But if you do power off and power on, the data is gone. But as long as you reboot in this persistent storage, basically you'll have all the data like this D message locks like this. Okay, so for this Pstore, it's nothing but your generic platform independent persistent storage. So basically what you do in that particular platform independent storage is that once you configure your ROM ops basically, so what will happen is the whenever your kernel goes into oops mode, so all the content of the ROM oops will get copied into this persistent storage. Okay, so for this, so basically first thing what you need to do is you need to configure, enable the Pstore file system. Okay, and then you need to configure your RAM oops. Okay, so for this basically you need to pass the following, you need to enable the following things. Okay, so what you need to do is you need to enable the Pstore. Okay, then you need to enable the Pstore console. Okay, then you need to enable the Pstore RAM. So all these three parameters you have to enable it in the kernel config. Okay, once you have enabled the kernel config, and once you have done it, we need to pass the following parameters to your kernel basically. Okay, so first of all you need to reserve this place in the DTB for this particular ROM ops, and we have to pass this parameter as a command line thing. Okay, so what we do is in this particular thing, I tell that ROM ops mem address where exactly this memory is starting. Okay, so where the Pstore should copy the data, that should be done. What should be the size of this, and what will be the record size that will be copied to that particular thing. Okay, so this, and after that we will give all this information. Okay, so once we do all this information and pass, and once we reboot the system, right, so what will happen once we boot our system. Okay, so for something like this, assume that I trigger the panic. Okay, so what will happen is the moment I trigger a panic, after 30 seconds, what will happen is my system will boot. So after the system boots, what will happen is the Pstore will be mapping to this. Since I've configured my Pstore kernel parameters with so and so address, the Pstore will be mapping to this particular memory, and it will copy it will create a new file called dmessage rom oops 0 or 1. It keeps incrementing each time it reboots. Okay, so all the console messages and the D message, everything will come and sit inside this. Okay, so like this we should be able to configure. So these are the few things we have to set for this particular thing basically. Okay, so in case of U-boot also, in case you have an U-boot, you using Pstore, there's a command called Pstore. So if you use Pstore, it will automatically enter the Pstore if it's set at which address the Pstore is available, right? If you tell that, you can go to that Pstore and you can display all the content of the Pstore. You can dump the content of the Pstore. So basically Pstore is nothing but a memory where is something like a memory file system, where what it will be doing is it will be putting all the data one after the other in that particular thing. For example, one dump is called as oops one, and other dump, this is the mechanism where it stores. Other dump will be stored as panic 2. Okay, so it will be displayed in a form something like this, in a viewable form, which you can view and analyze at a later point of time what really happened. Okay, so did you,
So
yeah.
yeah. Oh yeah, till this point actually I got. So here we will get all the D message, but
Yeah,
not the ELF file. Same like
no, no, no,
we.
no, not the
Oh,
ELF file, only the D message alone we will get here. That is the only thing what you can track here.
okay.
See, what you are doing is on the RAM. Okay, so here, so the assumption of the kernel developer is that whenever you have a small subsystem, right, where you can't capture the kdump or something like that, right? So they feel that at least D message will give a lot of information about, because you'll get KOOPS details, right? Once you get the D message, so you can solve a lot of things via the OOPS messages. So they want to collect the OOPS message via this D message logs.
Okay.
So you'll be able to capture only the oops messages, not in nothing else other than that.
Okay. So the DRAM, the processor size, all those things we are giving the above command you
Yeah,
showed.
yeah, 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 yeah. True. So in this case, say normally in this case, what I'm doing is I am reserving the memory, but nowadays everything is done via DTP. Okay. So what I need to do is in DTP, I need to reserve the memory, and I need to, once I've reserved the memory, I need to pass that memory detail into this command line parameter using ROM oops. Okay. So you can check here. I think it will be available even in this ROM. Oops. Okay. So you can just search here basically this one. Yeah. So these are the messages. It will be filled something like this. Okay. So basically what you will tell is you will pass this memory telling that 0x00, and I'm telling that this is the and it should have. So for example, I'm pushing it as some memory where it is an ECC protection. So I'm telling this, but I'm reserving the memory via DTP something like this. Reserve memory. Okay. So I'm telling that this memory is reserved for ROM oops itself at this particular address. Okay, so this, if I want to pass it directly, or else I can pass it via the DTB also. This is also possible.
So,
Okay.
but the address actually we how the starting address where we can keep the
You see normally if you are if you are developing the board, right, we reserve a RAM for each and every purposes.
you mean from the data
Data sheet basically.
data sheet only? Okay.
Data sheet, you need to figure out how much memory will your kernel utilize. In that memory, you should reserve some memory for this particular ROM itself, basically RAM ops itself. Okay, so it's something like this. I will tell you the clear information. Okay, so let me clear it. Okay, so normally what will happen is you will have complete RAM available for you. Okay, you will have the complete RAM available for you. Okay, so in this you can split up and use for specific purposes. Okay, so what will happen if you reserve some memory for k oops. Okay, so leaving this memory, other memory it will utilize for kernel things. Basically, it will not, you will use this memory at any point of time.
Okay.
You got it right, what I meant?
Yeah. Yes.
So this Pstore, this file system is in the format of Pstore. So the memory what you allocate is for k oops. Okay, but this file system is in the format of Pstore. Okay, so the Pstore format will be something like this, what you're seeing here. It will be in the format and not this one. We will look at this. It will be in the format something like this. Basically, if you look at it, let me show you. It will be in the format something like this: ** dump k oops message, then all the messages. Okay, then after that ** dump. This is another dump. Okay, then this is the panic 2. Okay, so then after that lot of messages, then .. console. Okay, so because if you see here there are two code d message and one console dump. Okay, so you're seeing all the messages here basically. Okay, so like this you'll be seeing all the messages which is saved here. Okay, so once once it is there, using there is another utility which is called Pstore persistent. Using that you can copy from this Pstore persistent. Using that you can copy into persistent storage like MMC, SD card, your hard disk. Okay, you can copy it wherever you want. There's a tool called Pstore persistent. Persistent. Sorry, there is. Yeah, this one. I'm sorry, where is it? Yeah, this one. Pstore service. Okay, so what this guy will do is he will he'll archive all the data from the Pstore basically to the desired location where you want. This guy can do it basically. Okay, so he will copy, to assume that you want to copy to somewhere else. You can copy everything from wherever you want. You can copy it and you can pull it to your hard disk wherever you want. You can copy it via this mechanism. Okay, so this will pull the data, but Pstore will only put the data in the format something like this basically. Okay, to understand this, we can do is so to know where exactly this configuration resides. Let me kill this process. So I will show you where this will reside. Okay, exit.
You mean that using the dd command we can, if you're storing in the MMC or SD card,
Yeah.
so in that case, how can we access from the user space?
Using DD command, is it?
Yeah, yeah, using dd or some command, right?
See, assume if you use DD command to copy, right? So what will happen is it's something like normal file. It will be visible in the format something like this only for you. It will not be in the.
But
It will not be.
directly we can't access, right?
You can't access it. See, you need to decode this Pstore format and understand what it is.
Okay.
Okay. In case if you copy via the utilities like the system services, right? What it will do is it will decode this. It will directly go to this folder, this particular folder. It is already decoded this data in the format something like this, and it will copy file by file to the to your persistent hard disk or persistent MMC card or SD card or something like that, basically.
Okay.
See, if you do DD, you'll be copying this data. So you have to decode what it means. So you need to know this is the start of one dump. Then you need to copy this and analyze later. Okay. So then if it one more dump comes, you should know that, yeah, this is another one. So you need to do everything you need to do by hand by yourself, basically.
Okay.
Okay. But if you use this, or one more way is instead of DD, once the Pstore is available, you can do a direct copy of this data to wherever you want, basically. Okay.
Okay.
So that way also you can do it. Okay. So I would, this is always, it is recommended to copy this file because this is a decoded format. This is not a raw format like this. Okay.
Okay.
Got it, right? Yeah. Did you get this point?
Yes, yes,
Yeah.